Recitation 10. So let's see the first one. So we want to use sum or difference identities to get an exact value. So we don't want to use a calculator to approximate. We want to get an exact value. Okay, so this one, we want to use the sum of sine of two angles. So we can write 7 pi over 12 as 4 pi plus 3 pi over 12, right? So each one over 12. And this can be simplified as a sine of 4 divided by 12, which is pi over 3. Then plus 3 divided by 12, that's pi over 4. So let's recall the formula. The formula sine of sum of two angles is a sum of sine, cosine, and cosine sine. So sine of the first one, sine pi over 3, and cosine of the second one, pi over 4, plus cosine of the first angle times the sine of the second angle. Right, so the value, so those are special values. Sine pi over 3, they have those angle pi over 4, angle pi over 3, they're special angles. So we need to remember their exact value. So sine pi over 3 is radical 3 over 2. Cosine pi over 4 is radical 2 over 2. Cosine pi over 3 is half. Sine pi over 4 is also radical 2 over 2. Right. Then the first two, radical 3 times radical 2, we get a radical 6. 1 times radical 2, still radical 2. So all divided by 2 times 2, which is 4. So this is the exact value of sine 7 pi over 12. Now let's see B. Cosine pi over 12. Cosine pi over 12, we could use a difference, right? We could use a cosine of 4 pi over 12 minus 3 pi over 12. So I'm using this one, right? Which is just cosine pi over 3 minus pi over 4. So cosine minus, that's minus. So this is a cos, so cosine of the first angle, cosine of the second angle, minus, minus or plus, sine pi over 3 times the sine pi over 4. I think it's opposite. Cosine is opposite, isn't it? Cosine should be opposite. Let me just check. Let me just double check to make sure. Sum of two angles. Cosine, cosine. Yeah, cosine is opposite. Yeah, okay. So I'm right about that. Sine is consistent. So sine, for sine, the sum of two angles, so this is a sum. For cosine, this is a difference, this is a sum. All right, so now let's recall those values. Cosine pi over 3 is half. Cosine pi over 4 is radical 2 over 2. Sine pi over 3 is radical 3 over 2. Sine pi over 4 is also radical 2 over 2. So we see this is the same as sine 7 pi over 12. So it's radical 2 plus radical 6 all divided by 4, right? You see those two values are the same. Why is that? Co-functions, right? So sine of 7 pi over 12 minus pi over 2, minus pi over 2, which is 90 degrees, right? Equals to cosine, equals to the cosine. So 7 pi, no, hold on a second. Let's use this one because I want to use cosine. I want to form pi over 12. So sine 7 pi over 12 equals to cosine 7 pi over 12 minus pi over 2. Okay. What's pi over 2? Pi over 2 is 6 pi over 12. So that's cosine pi over 12. Okay. So those two functions are co-functions. Sine 7 pi over 12 equals cosine pi over 12. Why? Because 7 pi over 12 plus pi over 12. No, I should do minus, right? And those two, so the complementary angles is 6 pi over 12. So that's why those two functions have the same value, right? Okay, let's see 2. 2, we see we have sine 3x cosine 4x, then sine 4x cosine 3x. We have applied this formula for the first one, for sine 7 pi over 12. So here it tells us that's just a sine of 3x plus 4x. Well, 3x plus 4x is 7x. So sine of 7x. Let's see 3 and 4. We were given sine x equals 1 over 8. And the angle is in the first quadrant. So remember the first quadrant, all 6 values, all 6 angles are positive. So we want to use double angle formula to find the sine of 2x, cosine of 2x, and the tangent of 2x. No. So let's find cosine 2x first. Because one of the formula for cosine of 2x is 1 minus 2 sine square of x. Which is the 1 minus 2 times 1 over a squared. That's a 1 minus, well, 1 squared is 1, a squared 64. 64 divided by 2, 32. 1 minus 1 over 32 is 31 over 32. And so that's cosine of 2x. Once we have cosine of 2x, and we can find sine of 2x. Sine of 2x square equals to 1 minus cosine square of x, right? Then we square root. Because the identity is sine of an angle, sine square of an angle plus cosine square of an angle, same angle equals 1. So we use this identity. Then we'll have a square root of 1 minus, well, cosine squared is 31 over 32 squared. So we get 32 squared minus 31 squared. So 1, we change 1 to be 32 squared over 32 squared. Well, 32 squared minus 31 squared, difference of two squares. So that becomes 32 plus 31 times 32 minus 31. Well, 32 minus 31 is just 1. So denominator of 32 squared. 32 plus 31, that's a 63. Divide, so square root, we have this square root. Then the square root of 32 squared is 32. So that's the sine of 2x. Now with the sine of 2x, cosine of 2x, we can find tangent of 2x. That equals the sine of 2x divided by cosine of 2x. Well, sine of 2x is square root of 63 divided by 32. Then divided by 31 divided by 32. So both have the same denominator. We can just cancel those two. So that equals to square root of 63 divided by 31. Okay, so we find all three values. 4, we want to use a half angle identity to get the exact value of cosine 15. So cosine 15 degree equals to positive 1 minus cosine, 1 plus cosine of 2 times 15, or 2 times 15, which is 30 degree, divided by 2. Then that equals to, what's cosine 30? Cosine 30 is root 3 over 2 divided by 2. So now we change this 1 to be 2 over 2. Right? We need a common denominator. So we have 2 plus radical 3. So we have 2 plus radical 3 divided by 2, then divided by 2 again. Well, three layers of fraction, we just multiply the two denominators. So we get a square root of 2 plus radical 3 divided by square root of 4. Well, square root of 4 is just 2. So that's the answer for 4. Let's see 5. 5 is the last one. 5, we want to use double angle identity. So we see sine, we see cosine. Remember sine of 2x equals to 2 sine of x cosine of x. I will use this identity. So see here we have sine of pi over 4, cosine of pi over 4, and this will have 4. 4 we can change to be 2 times 2. Then 2 times sine pi over 4, cosine pi over 4. That's just a sine of pi over 4 times 2. Pi over 4 times 2 is pi over 2. And we still have these 2. Okay. So equal to 2 sine of pi over 2. Well, what's sine pi over 2? 1. So that just equals to 2. Okay, so that's the last one.